Hi everyone, this is the third video for day 2 of week 3. So far we've looked at trigonometric ratios. We saw how they can be converted to functions, how to use the calculator to find specific values of the function, and a separate procedure for secant, cosecant, and cotangent. And next we're going to do something called inverse trigonometric functions. Now, inverse of a function, not to be confused with the reciprocal, it gives us the input when we provide the output. For example, if you walk into a room and you notice that the light is on, you can draw the conclusion that the switch must be on. Right? Now, for somebody who turned on the switch to turn on the light, for them the input was turning on the switch and the output was that the light is on. But for you as an observer, you can see the fact that light is on is the input gives you that the output is that the switch is on. So in terms of trig function, recall how previously we said that the input is an angle and the output is a ratio. For inverse function, given the ratio, so the ratio is the input and the angle is the output. Now how we do this is we use these buttons on the calculator. This is read sine inverse, cosine inverse, and tangent inverse. Now on the calculator, you will find them exactly above the sine, cosine, tangent button with a different color. Now that color should match up with the color of this button called second, which means to access it, you have to first press second and then this button. So let's see how to set these problems up. The sine A equals 0.83962. And that's a ratio. And you're trying to find A, which is the angle. So for the first step, you're going to write A equals sine inverse of this number, 0.83692 equals, and then you plug into the calculator. So let's see, second, or let me clear this up, second sine. So sine inverse, 0.83692. 56.82 degrees. Once again, make sure your setting is on degrees. Now when you're going through this video and you use your calculator and these numbers don't match up, that means that it's not in degrees. To check if it's in degrees, it's not very clear here, but over here it would say DEG. The same goes for the rest of them. So A equals cosine inverse of 0.23695. Let's see, let's move this here. Cosine inverse of 0.23695 gives me 76.29 degrees. Tangent inverse of 0.59334, second tan 0.59334, 30.68 degrees. Now recall how we had a separate procedure for secant, cosecant, and cotangent. The same goes for inverse as well. Again, the reason being we don't have these buttons on the calculator. Now in this case, when you're finding the angle, we're going to go from secant to cosine, recalling that cosine is 1 over secant. So cosine of A is 1 over secant A, which means it's 1 divided by 1.58732. So I calculate this, 1 divided by 1.58732. And I will try to keep the same number of decimal places as this. So 5 places. 0.62999. Now the sixth number is 2. Because it's less than 5, this remains 9. Now this question has been converted to the second. Right? You have a value for cosine A, which means A is going to be cosine inverse of 0.62999, which you can now plug in here as cosine inverse of 0.62999 to give 50.95 degrees. Right. There's an alternate way in which you can do this in one step, or where you don't have to copy this value. So let's try that example with cosecant. So cosecant A is this. It means sine A is 1 divided by 2.08363. Now here, instead of doing this division first, you can also just apply the inverse to this division. So skipping the step where we write this value. So how does that look on the calculator? You go sine inverse 1 divided by 2.08363, and that's going to directly give you the 28.68 degrees. Now I'm going to skip one more step, and I can just remember that cotangent means I use a tangent is as a reciprocal. So this is going to be tan inverse of 1 divided by the cotangent value 6.06790, which once again I plug into the calculator. Tan inverse 1 divided by 6.06790, 9.36 degrees, rounding off to a hundredths place. Okay, so that's the end of day 2 videos. We've covered how to use a calculator for trig functions as well as inverse trig functions. And you can take a look at the worksheet. I've also uploaded the solution to the worksheet, but I would suggest you go through the worksheet yourself first, and then if you're stuck or if you want to verify your answers, you can look at the solution.